Okay, so we just went over the concept of stroke volume. Now I want to introduce another concept to you, cardiac output. Okay, cardiac output is the volume of blood pumped out of the heart per minute. In other words, or mathematically, that's going to be your stroke volume times your heart rate, right? So stroke volume is how much you eject each time your heart beats, and your heart rate is how quickly your heart beats. Okay. I also just want to point out that cardiac output is going to be the same as the rate of blood flow through your entire body, right? So if you were to look at the amount of blood, the total amount of blood going through all of your capillaries at once, it would be the same as the cardiac output, right? Because that flow rate through your body has to be the same everywhere. Otherwise, if that didn't happen, you would end up with a buildup of blood somewhere in your system, okay? And like a backup of blood. And you don't want that, okay? So, as you might guess, I have a task for you to perform right now. What is the cardiac output here? See if you can calculate the cardiac output. So go ahead and hit pause and see if you can calculate that, and we will go over the calculation.
Okay, so let's go ahead and calculate our cardiac output here. First of all, I just want to start by saying the cardiac output was 5.25 liters per minute. So if you were able to calculate that on your own, you can go ahead and skip this part of the video. I think it'll be about 3 minutes. For those of you who do need a walkthrough through this calculation, I will do that now. So remember, cardiac output is volume of blood pumped out of the heart per minute, which is going to be the heart rate times the stroke volume. Okay. We already know from the previous slide that stroke volume is 70 milliliters. So our task here is to find out what the heart rate is. To find out the heart rate, we can look down here at this graph. Okay, it's a little bit tricky, but basically what you want to do is you want to look for one full cycle of the heart, right? So one full cardiac cycle. What I did was I started at the beginning of atrial systole and I went through and found the beginning of the next atrial systole. Okay, so we know that one beat is going to take 800 milliseconds, right? Because that was 800 milliseconds from the beginning of one atrial systole to the next atrial systole. So that's our heart rate. It's one beat per 800 milliseconds. However, we do want to convert that to beats per minute. So we're just going to do some conversions here, right? So we know that we have 100 milliseconds in a second. We know that we have 60 seconds in a minute. And that's going to give us a value of 75 beats per minute, which you could also write as BPM. Okay. All right, now we know our heart rate, so we can take this value and substitute it back in up here. Okay, so just to write that out again, cardiac output is going to be equal to the heart rate times the stroke volume, which is in this case 75 beats per minute, times the stroke volume, that's 70 milliliters, and that's basically 70 milliliters per beat. Okay, and that is going to give us a value of 5,250 milliliters per minute, or 5.25 liters per minute. Okay, and this is, I should point out, this is a pretty typical value for cardiac output. Cardiac output is usually about 5 liters per minute.